wonderful students. I want to welcome you to Eko Learners Support for WAEC and NECO candidates. My name is Eko Joseph. I'm your instructor for today's chemistry class. So I want you to sit back and let's enjoy as we dive into today's topic. Good one.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Wow, never mind what you are seeing on my screen. I just want to use that to dive into what we are to do today. That is the chemistry words. Apparatus, I hope you are familiar with that. So can we enter the chemistry lab? Good, let's enter. What is going to be our behavioral objective for today's class? If you will ask me, we need to explain what we call alkenes. Alkenes, do you hear what I said? Okay, fine, alkenes. The unsaturated hydrocarbon. Okay, don't mention too much. Don't worry, let's enter. The next one is naming of what? Unsaturated what? Hydrocarbon. So in this case, we'll be diving into alkene and alkyne. How to name them. Good. And explain the laboratory preparation of what? Ethene. We have a lot to do. Don't let us waste our time. Let's go straight to the business. I have what? Alkenes. Yes, alkenes. You need to understand that they are what? Homologous series of hydrocarbon with the general molecular formula of what? That is the first thing you need to know. CnH2 what? N. Where N can be any whole what? Number. But not one. Not one. Not one. So the first member of this family, you need to know that the first member of this family will be what? When N is 2, and that will be C2H what? 4. The first member is what? 18. So if you are asked the sixth member, that will be what? When N is equals to what? 7. If you are asked the seventh member, that will be when N equals to what? 8. The first member is when N equals to what? 2. Take note of that. So they have a general molecular formula of what? CnH2n. Fine. Yes, they are more reactive. Why are they more reactive than alkanes? Because they have what? 2 available electrons. Because they are what? Unsaturated hydrocarbon. Good. Automatically, what will be ringing in your mind is probably they may undergo combustion and basically addition reaction. But never mind. When we get to the what? When we get to the river, we shall cross. Okay, good. Remember, they have the double bond. Note that. Good. Let me undo my pen. I want to undo it and then move to the next slide. So, I have told you already that they have a general molecular formula of what? CnH2n when N is the what? Number of carbon atom. And I've told you the N starts from what? 2. And as you can see, this is the first member of this what? Family. And this compound is called what? Ethene. Don't forget, with a what? With the double bond in between it. And I've told you the carbon is what? Tetravalent element. So 2 plus the 2 bond making what? 4. Good. Let's move because we don't have plenty time. Yes, another what? Another unsaturated hydrocarbon is alkyne. But I'm going to talk more about it when I enter the family of what? Alkyne. But you need to know they have what we call what? Yes, triple bond. They are more reactive than what? Alkenes. Why? They have 4 available electrons. Unlike what? The alkenes that have just 2 available electrons. They are triple bond, as you can see. The other one is double bond, right? Automatically, it should be more reactive than what? Alkane. Good. With the general molecular formula of what? CN, H2N, minus 2. Don't forget about this. It will help you a lot when you are naming the compound. But we are still going there very soon. Now, naming of what? Rules for naming alkenes and alkynes. They are both unsaturated hydrocarbon. So when you want to name it, you must be what? You must consider some what? Some factors. The first thing you must consider is you have to select what I call longest continuous what? Chain. Let me pick my pen. Sorry about this. Let me pick my pen. Okay, fine. Again, longest continuous chain of carbon atom that contain the double or the triple bond. Telling you that you need to be aware the position of the what? The double bond and the single bond. Oh, sorry. The double bond and the triple bond. Good. Yeah, for alkane, the root name of the what? Carbon atom is the same as for the what? Alkane, except that the ANE, good, is replaced with what? E and E. Please note that. And a good example is what we show. Why the ANE of this one too is replaced with what? Y and E. And the example, ethane from alkane. So what happened here? The ANE has turned to what? ENE when it gets to what? The double bond. And the ANE is turned to what? YNE when it gets to what? Alkyne. It's so simple. So once you know alkane, it's easy for you to start naming other words compound by just replacing them with either ENE or YNE, as the case may be. Oh, wonderful. Okay. Let me undo, move to the next one. Okay, fine. The third rule. So what's the third rule? The number, the parent chain, starting at the end, closest to the double or triple bond. And the location of the what? Multiple bond is given by the lowest number chain, number carbon involved in the bond. What are we saying? You know, in chemistry, we don't talk too much grammar. We talk reaction. Now look at the position of the double bond. So it's very wrong for you to start your naming from here. 1, 2, 3, 4. Why you are not giving preference to the what? To the position of the double bond. Rather, you start from here. But if you start from here, your double bond will be on position what? 1. But if you start from here, it will be on position what? 3. You need to get note to that. Give preference to the what? To the double bond or the what? Triple bond. So how will you name this? 1, 2, 3, 4. So instead of, look at it. Remember, butane, but what happened here? It will change to what? ENE. So it become but. What's the position? 1. In. So simple. But 1 in. You are telling me that the 1 is telling us that the double bond is in the position of what? Carbon 1. Or you call it 1 butene, as the case may be. So what happened to this? See? Oh, you are lucky. If you start from here, and you start from here, you will still have your double bond at position what? 2. Either start from here, the double bond at position 2. So instead of, remember, I want you to get used to it. You change the this to what? ENE. So it become boots. The position now is 2. So it become boot 2 what? In. It's simple as that. Fine. Then the next one is what? The substituent. These are very important. On the parent chain are treated the same way as in naming of what? Alkane. So simple. So we have to look for where the word substituent is. Look at the compound. So the first compound is this. Look at this compound. So this compound, I have Cl, CH, oh, sorry. Let me pick my eraser again. Let me cancel this. Pick my pen again. Then you have Cl, CH, the double bond, CH, CH2, then CH3. Look at this. So I have to look at the position of the double bond. Good. So if I start from here, 1, so this 1, so this 2, so this 3, this 4, or you start from here, 1, 2, 3, 4. So you discover that if I'm starting from here, the double bond will be on position 3, which is far away from the what? From the double bond, but if I start from here, it will be on position what? 1. Good. And when you look at this becomes the what? The attachment, the substituent. So it's equally on carbon what? 1. So all I need to do, I have to talk about the position. So I say 1 chloro. So why is it 1 chloro? Because the chlorine is on carbon 1. Then 1, 2, 3, 4. That will give you what? Boots 1 in. So simple. So simple. 1 chloro, boots 1 in. You can go back and do like this. It's the same thing using structural. Then here, you put your what? Cl. So this hydrogen. Hydrogen. You support it with hydrogen. And that will give you what you are looking for actually. So, then, oh, sorry, I have to put my double bond here. On that note, let me pick my eraser and erase this. Okay, fine. So I have what? 1 chloro and what? Boots 1 in, showing the position of the double bond and the substituent. Okay, fine. So let's move. Oh, good. Name the following compound. I hope you can name the following compound. So what you need to do, you start from, if I start from here, I have 1, 2, then I have 3, 4, 5, and 6. Or you move 1, 2, 3, 4, 5, and 6. So you discover that if I move from here, although my words, substituent will be on carbon 3, but if I go from here, it will be on carbon what? Carbon 4, if I go from here. But this double bond is very key in this, is at carbon 2, so I have to consider heat. So my starting name will be from here, but wherever I'm coming from here, I have it at carbon 2. So in this case, you come 1, 2, 3, 4. So at carbon 4, I have the methyl. Then at carbon 2, I have the double bond, then 6 atom. So I have to start with this for 4 methyl. Then what? 6 is what? Yes, X, 2 in. Why is it X? X means what? 6. So why is it 2? Because it's on carbon what? 2. Good, you are good to go. So likewise, when you come here, the same thing. See the movement. If I go like this, 1, 2, 3. Oh, 3. Then this 4, 5, 6, and 7. Too long, but let me start from here. 1, 2, 3, 4. Even 5, 6, and 7. Or you go 5, 6, and 7. So the same. So if I come like this, 1, 2, 3. At carbon 3, I have my triple bond. Then at carbon 5, so I have my what? Ethyl. Then the carbon atom is what? 7. So I will start from 5, ethyl, then hepta, that is hept. At what? 3 dash in. It's showing the position of the what? Of the double bond. This shows the position of the attachment. This is ethyl. So this ethyl is on carbon, what will you call it? I hope we've not, oh, you see, if you have started, okay, let me see, 1, 2, 3, 4. 1, 2, 3, oh, good, good. So you have 5 ethyl, because we have to start from where it is easier, where it's closer to the what? Triple bond. 5 ethyl, hept 3 heme. Good. So for you to have a better understanding, you keep what? Trying and trying. The first rules, make sure you what? Concur with it. The second, the third, and the fourth. So if you have the functional group, take it as your priority. Okay, fine. Yeah, this exercise, we can do this. We do this in the next class because we quickly need to move to laboratory preparation. So how can we prepare? Yes. How do we prepare the first member in the lab. And the first member is what? Ethene. So how do we prepare ethene in the lab? Yeah, for us to prepare ethene in the lab, we need what we call ethanol. What? We need what we call what? Ethanol. And we need what we call concentrated H2SO4 tetraoxosulfate what? 6 acid, as you could see. So what happened here is tetraoxo 6 acid is reacting as what? A dehydrating what? Agent. Look at that word. Dehydrating agent. Yes. So look at this word. Dehydrating agent. You need to understand. So what the meaning of dehydrating agent is removing water from the what? From the ethanol. So if you remove water from that, what you are going to, you will be left with what? Ethene. It's as simple as that. But the reaction is 2. This is HSO4 minus plus. So the first thing we give this, then later this one will split again to now give what? This one will split again, but then you remove water to now give this and this. So basically it's very simple. From the ethanol, just remove what? Water from it. So H2SO4, conc H2SO4 is acting as well dehydrating. Dehydrating. Hydration means you are removing water from the ethanol. And when you do that, what do you get? You get ethene. So that is good for us. So let's quickly move. They're in the lab. Yes. So you can be asked to do the laboratory preparation of what? Ethene. It's very simple, the concentrated. So look at the, let me pick. So this is the concentrated acid. So this is ethanol. So the concentrated acid is acting as well, dehydrating. You know, I've told you what a dehydrating is. You are removing what? Water molecule agents. Yes, water molecule from what? Ethanol. And when it happens, yes, you have to pass it through what? Empty what? Flask. So while we're passing the gas generated there in order to prevent what? Sucking back. We don't want the gas to go back into the what? Into this particular what? Solution. So this will help the gas from going back into the what? Reaction what? Mixture. So while we're passing it through this, yeah, we're passing it through this because there could be a production of what? CO2 gas in the process. And what happened? This will absorb the CO2 gas. Then this collection is called upward delivery. So this collection is called upward what? Delivery. So why are we using upward delivery? Because the gas is lighter than what? Than air. Then you have your ethene in this. You discover that they are passing it through water because it's not extremely what? Soluble in water. You need to know this. So on this note, so can we move? So we can move. Okay, fine. Yeah, this another thing that is very, very essential. Yeah, ethene industrially can be prepared by what we call cracking. Cracking or what? Every hydrocarbon. So when you crack every hydrocarbon, the product you obtain is what? Alkenes. And the example of this alkene is what? Ethene. So ethene can be what? Produced industrially by cracking. So this is the paraffin, the heavy hydrocarbon, is being heated. So when it is heated, so what happens? Strong heating in the presence of what? Aluminum oxide. So we call it catalytic. This process is called catalytic what? Cracking. Catalytic what? Cracking, because it involves, yes, aluminum as what? As a catalyst. So when it happens, it goes down to the water and the ethene gas is being what? Ethene gas is being produced. So please note that industrially we can produce what? Ethene by what we call catalytic what? Cracking. And this is actually what happened in the production. So this is the heavy compound. Then you have H2O3 at about 450 degrees Celsius. So what happened? So the major product here, so this is the major product. So the major product is what? Ethene. It's very, very essential. Equally, you can go in this particular direction. And why do they do this? It's very simple, because some products are more what? Yes, need like a petrol now. More customer buy petrol, more people is needed in what? In high quantity. And what happened? Diesel in less quantity. So if the demand is very, very high in petrol, scientists can decide to what? To heat the diesel in order to produce what we call petrol. Okay, fine. In that direction, we keep moving. So let's move. So what are the physical properties? So it is a colorless gas with what? Faint, sweet what? Smell. So it's easier to know this. It's primarily what? Soluble. That's why we can pass it through water. Yeah, it is slightly what? Less dense, I've told you. That's why it can be collected by upward delivery and has no, yes, action on litmus paper. I've told you most of these gas acts no action on both blue or red litmus paper. Wonderful. We can move. Yes, what are the chemical properties? There are a lot of it. There's a lot of chemical properties. So the basic thing here is it can undergo what we call combustion. Yes. So what we call combustion, reaction, and what we call addition. Yes, reaction. Why? Due to the what? Reactivities of this particular compound. So you'll be going from double bond. You'll be going from what? Double bond to single bond. If you, okay, let me put H2. Then this will go to single bond. Always note that this reaction is to move from double bond towards a single bond. Yes, so this is how it looks like. Okay, fine. So I can move. Yes, fine. Also, it decolorizes what? Bromine water. Yeah, you see, it decolorizes what? Bromine water from reddish brown to what we call, colorless. So please note that. Also, we are going back to basically the uses of this particular what? Compound. Yes, so ethene, it can be polymerized. Another chemical property you need to know. Yes, so form what we call polythene. So the polythene here, the reaction is you have C2H4, at least 2 molecules, then to form C. So this double bond, and this is what we call polyethene. So this reaction is called addition polymerization, and these are the products obtained. Look at it. So these crates are made from what? Polythene. Good. Yes, then when chlorine is added to the what? Compound, when the chlorine is added to the compound, it becomes what? PVC, polyvinyl chloride. Okay, so in this case, this is the structure of polyvinyl chloride. So what are the uses? It is used in the manufacture of what? Plastics, so it's very important. It is used in making synthetic rubbers, all these rubbers. Yes, ethene is useful in hastening the ripening of fruit. So most of the food that they are ripe by chemicals, you think about what? Ethene. Okay, so in the production of what? Ethanol. Remember, the sulfur is so essential. Yeah. Okay, good. So the question here now is, we are to what? Do this. So I want you to take 2 minutes, answer the question. I hope you have answered the question. Oh, that is wonderful. Good. So let's go together. Now look at the answer. So the first, we are to what? Look at what they said. What's it called? 1, 2, 3, 4, 5, 6, 7. So this will be what? You remember the first member is what? 18. So 1, 2, 3, 4, 5, 6, 7. So the sixth member will be what? You remember the sixth member? The sixth member will be what? 1, 2, 3, 4, 5, 6, 7. So that is what? Ethene. It's very simple. The first member is 18. If the first member is 18, then the sixth member will just be what? Ethene, which is 7. Good. And we are told to determine the molecular formula. So the molecular formula is very simple. So write the molecular formula C7H 14. The molecular mass will be how many you have? So we have carbon 7 times what? Carbon plus 14 times hydrogen. Then 7 times 12 plus what? 14 times 1. Don't forget the relative molecular mass of hydrogen is 1. So in this case, you have 84 plus what? 14. And that will give you what? 98. On this particular note, I want to say you've been enjoying the class. In case you have questions, comments, suggestion, I want you to drop it on the link that will be displayed on the screen. Thank you. Wish to see you in the next class. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.